super fun. But
You think everything is super fun. Math problems on your own time.
okay. What did you guys get when you multiplied all this together?
2x cubed minus 3x squared plus minus 3x.
Whoa. So 2x cubed minus 3x squared
Minus 2x plus 3.
plus 3. Confirmation all around? Yeah? Okay. Good. So that required a lot of work. My question to you is, first of all, what's the leading term? Leading term.
2x.
2, this is the leading term. All right, the lead term, 2x to the third power is the leading term. Not just because we put it in front, but because this is the one with the highest power. Therefore, the most important, because he's got the most power, like Superman. Okay? This is the leading term. The leading term is super important when we're trying to graph polynomial functions. So my question to you is, did you have to multiply all those bubbles together to figure out the leading term? No. What could you have done to find the leading term?
Well, the first term.
2x times x times x. And then you get 2x cubed. Great. Shortcuts are nice, right?
Yes.
Okay. So we're graphing polynomials in factored form today. So my polynomial is nicely factored. I can tell a ton about a polynomial in factored form. We do need to know the leading term because it tells us a lot of information. So we're going to talk about that, a lot of information. So the first thing is the leading term test. I don't know if it's a test, but it, oh, that is not straight. Sorry. All right. Better. Okay. All right.
Oh my gosh, she's a pro.
Okay. The leading term test. Knowing the leading term is super duper important for our polynomials, to be able to sketch them. Our polynomials actually only have 4 different ways that they can be drawn. Okay? And by drawn, I mean the arrows. There's only 4 different ways that the arrows can go. All right? So for instance, you guys know that something like, I don't know, 3x squared. What does that look like? It's a U. It's a parabola. Yeah, you know that, right? Yeah. So you know that that's a parabola, and it's something like that. Now, there would be a bunch of other terms on there, but the leading term is 3x squared. Okay? And what that 3x squared tells us, we learned 2 things from this. This is the power is even. Oh, I'm out of bread. That's really sad. Okay. Even powered function. And the way that I think about that is the arrows match. They're even. They're the same. They both point up. Okay, they're even. They match. Okay. What happens when we put a negative in front?
It's sad.
It goes down. They both point down. Yeah. So again, we have those, that power is even. So the arms, the arrows match. Why did they point down?
It's sad.
Because it's negative. Okay. So that's what the leading term tells us. If we have an even power and a positive in front, then both arrows are going to point up. Up high on the left and high on the right. It's true for any leading term that's like got a positive number in front and an even power. So positive x to the 4th and positive x to the 6th and positive x to the, oops, that meant to be an 8, and positive x to the 22nd. The arrows are always going to be both arms up. Okay? Always. Because of the even power. Very interesting. The same is true if we put a negative in front. If it was negative x to the 4th and negative x to the 6th or negative x to the 8th, the arrows are still going to point down. Okay? All right, so now this is the even side, either both arms up or both arms down. What does x cubed look like? A little squiggle, okay. Does it start low on?
Yes.
Low on the, okay, so it's a little squiggle like this, yeah. All right, I call these odd arms. Why? Yeah, they're crazy arms. One's up high and one's low, okay? So I call those odd arms, and the power is odd. The number in front here is a positive 1 in this case. Positive, meaning it's going uphill from left to right. It is an increasing function, okay? What happens when we put a negative in front of that x cubed? It flips and decreases. That's right. Okay, and that again is true for any odd, that's supposed to be an O, any odd powered leading term with a negative. It starts up high on the left and ends low on the right. It's going downhill overall. Okay? If it's a positive x to the 5th and positive x to the 7th and positive x to the 13th or x to the 15th, they all have arrows that start low on the left and high on the right. And the same is true if we have negatives in front. A negative x to the 5th or negative x to the 7th or negative x to the 9th. They all start high on the left and end low on the right. Okay? These are the 4 different things. You can either have positive even arms or negative, or increasing odd, decreasing odd. Okay? So those leading terms are going to tell us about the arrows, and the arrows are absolutely important for us to be able to graph. So here we go. So we want to graph the function. Now, you've done a little bit of this already. So you'll notice we got lots of factors here. We have f of x equals negative 2 times the quantity x plus 3 times the quantity x minus 3 and x plus 4. So the first thing I want to do is find the leading term. LT stands for leading term. Okay. What's the leading term? Negative 2x cubed. Very good. Because negative 2 times x times x times x is going to give us negative 2x cubed. So what do those arms look like? What do the arrows do? They descend. So high on the left and low on the right. All right. High on the odd arms, crazy arms. One's high, one's up. High on the left, low on the right. Well, that was easy. So then we need to find the zeros.
It's too easy.
So since it's already factored, finding the zero is really easy, right?
Yes.
Okay, we get x equals negative 3, x equals positive 3, and x equals negative 4. Excellent. And none of those are repeated, which means they all have what's called multiplicity 1. We'll talk about that. Multiplicity 1, I'll write that down. Multiplicity 1. Multiplicity 1. Multiplicity 1 just means that our graph is going to pass straight through, like a linear function, like a line. It passes straight through that 0. So what we're going to do is we're going to go ahead and plot our zeros, our x-intercepts, negative 3, whoops, positive 3, And, oh, -4. There we go. How what? How does that pass through all things? It's got a squiggle.
Does it bounce a lot?
So here's what we do. It doesn't bounce. It's all of these are multiplicity 1. Multiplicity 1 means that we pass straight through each of those zeros. Now we are going to have to turn around. But my arrow says we're going to start up high on the left and we're going to end low on the right. And now I just have to pass through each of those zeros. All right, so I'm going to pass through. So I got to pass through this one. There you go, I passed through. Then I have to turn around quickly and pass through the other one. And then I have to turn back around to pass through my final zero. And I'm always going to start on the left side of my graph, but that's just me. How do you know if you did it right?
Check the rainbow.
Check the arrows.
Just graph it, right?
Graph it on your calendar, absolutely, okay. But what's cool is that we can predict what it's going to look like. Now, I don't know how high this goes up. It probably goes quite high. But you'll notice I didn't put any markings on my y-axis.
Right.
Yeah.
So it could mean anything. Okay? But you could imagine you could check this on your calculators just by plugging in the original function. Whoops, not cosine. X plus 3 times x minus 3 times x plus 4. And see, pretty good.
Wow.
All right, I could zoom out. I could change my window so that's a lot higher. I don't know how high it needs to be. Oh, higher than 50. Higher than 50. Try 100. There you go. So, I mean, that could be my graph, right?
Yeah.
Yeah, it could be. But that's what I think is kind of cool about graphing polynomials. So let's see what else happens here. So these are all multiplicity 1, which means you pass straight through. It's to the first power. They're all just one of those factors. And meaning it's like a line, x to the first power. When you zoom in real close to that 0, it's a straight line almost. Sorry, church business. Okay. All right, so let's look at letter B. The first thing we want to do is find the leading term. What's our leading term?
X cubed. X third.
X to the third. Very good.
Oh yeah, I can't.
Oh yeah, so here's x.
I don't know how to do math.
And then this would result in an x being squared. So we have x times x squared is x cubed. What do those arms do?
Do the same thing as last one.
Really?
They lag on one. Oh yeah, it's not negative.
Since it's positive x cubed, it's going uphill from left to right. Odd arms uphill.
This one is
Arms.
Doesn't it repeat over 3?
Yeah.
Okay. All right. So then, what are the zeros?
There's
One
one
and
and
negative
-3 twice.
-3 twice. Very good. That one's repeated. That's called multiplicity 2. X equals 1 is multiplicity 1. There's only one of them, if you will. But -3 is being repeated. It's got multiplicity 2. All right. Multiplicity 1 is a path straight through. Linear-like. X to the first power-like. If this is multiplicity 2, we talked about it, I mentioned it yesterday. I call it a bounce, but the math that's actually happening is it's multiplicity 2. It's x being squared. What shape is x squared?
Square.
Parabola.
No.
Parabola, right? A parabola. So when we have something that has multiplicity 2, it looks like a little parabola. It hits the 0 and bounces away like a parabola, okay? So we could, so we'll see, let's see, I'll draw it so you can
I
see.
don't know if I really like that.
Persevere.
1, 2, 3, -3, and 1.
I feel like it disobeys the laws of math because isn't it supposed to touch its twice? That's why it's.
What?
So, but no, I mean, if I touch something once, it's like
It's like
I could touch it an infinite number of times and no one would ever know.
Okay.
All right, so here we go. My arrows here are going to start low on the left, and it's going to end up high on the right. And so I'm going to start down here on the left side of my graph, and the first zero I'm going to approach is -3. And at -3, I have to bounce off of it, which really means that it's going to look like a parabola if I'm just looking real close to -3. It's going to be parabolic in shape. Okay.
Parabola.
All right. And then I'm going to turn around and pass through the 1, and I have to pass straight through like a line. So I got to turn around and then pass straight through it like a line. Okay. So again, you can always, if you're unsure, check, using your calculator. Uh-huh. Uh-huh. All right, so you can see my graph, pretty darn decent. Okay.
Oh, so you're saying.
How about minimum? That.
So at -3, because it's being squared, it looks like a little parabola. If you were just to like look at that little part.
Yeah. So if it has multiplicity too, it'll never go through the x-axis. It'll just touch it.
It just touches. That's exactly right. Good question.
Bruh.
It will go
Said
through.
good question.
But we'll get there. All right, so we have f of x equals -1/8 quantity x minus 3 squared times the quantity x plus 1 squared.
No.
They're not harder. All right. Leading term. What's the leading term here?
Something.
We got a -1/8.
X cubed. 4.
Good. This is x being squared, so that's x squared, and another x being squared. So -1/8 x to the 4th is our leading term. Are those odd or even arms? Even arms means they're both up or both down. Are they up or down? Both down. So crazy stuff happens in the middle, but both arrows pointed downward. Okay. All right, what are the zeros? +3, multiplicity.
2 and -1 multiplicity 2.
Good. X equals -1, multiplicity 2. Why? And we know that just because it's being repeated, the power there. Okay. All right, so I'm going to plot some values here. 1, 2, 3. And -1. All right. And I know that my arrows are both low on the left and low on the right. I'm going to start on the left side. The first zero, the leftmost zero, is -1. And I have to bounce off it. So I'm coming up and just touching that 0 and returning. Looks like a little parabola. And then what do I have to do at the 3? Same thing. So I got to turn around and make a little parabola to bounce off that 0. Yep.
Cool.
It's 2 little parabolas. Yes. X minus 3 quantity squared times x plus 1 squared. There it is. All right. They're kind of, I mean, aren't they cool? I think they're such neat shapes. All right.
It really looks like the Mario
Yeah.
It really
All right, last one. I think. Yeah, okay, good. What's the leading term?
1/5 x to the 5.
X to the 5th. Very good. We've got x cubed times x squared, which is x to the 5th. Are those even or odd arms? Odd arms. Uphill or downhill arms? Downhill arms. Going downhill from left to right because of the negative. All right, so we have zeros of x equals 1. What's this multiplicity? Multiplicity 3, because again, it's being repeated 3 times. And then x equals negative 3 with a multiplicity 2. Okay. All right. So let me show you. So a cubic, so since I've been talking about this, if it's multiplicity 2, it's being squared, it looks like a parabola. Multiplicity 1, it's x to the 1st, it looks like a line, it passes straight through. Which stands to reason if it's multiplicity 3, it's an x cubed graph. So I guess we need to know what that actually looks like. It's a squiggle, yeah. And so what I like to call this is, you'll notice it sort of slides to the right. So that's what I call it. I call it a slide to the right. All right, so you increase and then it slides through. Does that you kind of see that?
Okay.
All right, so that's what multiplicity 3 looks like. So 1, 2, negative 3 is a 0, and 1 is a 0. And my arrows start high on the left and are going to end low on the right. So negative 3 has a multiplicity of 2. What am I going to do at negative 3? Bounce off of that or make a parabola shape, so it just sits on that 0, just sitting on it, just touching. Tangent, it's called tangent, just to touch. That's literally what tangent means, to touch.
Right.
Yeah.
Alrighty then.
Okay. And then I need to get to the 0 at 1 and slide through it, slide to the right. So I'm going to turn around and approach on the left and slide like a water slide through it. Okay, slide to the right. You sort of run along the axis a little bit. You're not actually going horizontal, but it looks like it. So negative 1/5 x minus 1 cubed times x plus 3 squared. It's pretty cool, right?
That's like a terrifying roller coaster.
Terrifying roller coaster. Super fun. Super fun. All right. Roller coaster graphs is really what we call these. So do you guys have any questions for me? All right. There you go. Have fun with that.
Creative, bro.